Hi, in this video we're going to be looking at how you can create data from SPSS output using the SPSS output management system. So to start off, we're going to run a principal component analysis in SPSS to create some PCA component scores as part of the output in the SPSS viewer. And I'll just show you how you can actually manually graph those scores within the output viewer before we introduce the concept of the output management system. And this is going to allow us to do the same thing, but to do it in an automated and systematic fashion. And we're going to do that by specifying an OMS request that's going to monitor the output viewer and look for specific types of tables to turn those tables into data. And when we turn them into data, we're going to be able to create a chart from that data and even apply a chart template. And we're going to do all of that within SPSS syntax. Let's have a look at how that's done. So here we are looking at the SPSS data viewer. We've got a data set open. It's called world.zav, and it's a data set that's often used to illustrate principal component analysis or factor analysis. These are dimension reduction techniques. We've got lots of different fields here, and we're going to try and create component or factor scores from these fields. You can see that the fields measure things like socio-demographic and geographical features such as the population in 1960 for each country and the life expectancy in each country. So a lot of health related data here. We've got percentage of urban population. We've got the actual area, land area, the size of the country if you like. We've got education, percentage of GNP for education in 1960. And we're going to basically try to run a PCA here, principal component analysis, which is going to reduce these down to a smaller number of dimensions. And we're going to try to graph the scores in each of these dimensions, or the components as they're called. So if I go to analyze to do that, I'm going to go down to dimension reduction and calling up factor here, which is factor analysis. As you can see, the method that's going to be used. We're actually going to request principal component analysis, which is a kind of simple version of factor analysis. I'm not going to go into the details of that too much. We have lots of information about that on our website if you want to explore it in more detail. All I'm trying to do here is create some output for us to illustrate the OMS procedures and the OMS platform. I'm going to ask it to perform a rotation. That makes it easier to explain the results. Normally Varimax or Equimax is what's used. You can see that the extraction type it's going to use here is PCA. The other types are factor analysis, so principal components is the kind of standard technique. And if I go to options here, you can do things like sort by size. That just makes the coefficients easier to display because they put the biggest coefficients at the top and the weaker ones at the bottom. And you can even suppress the weaker coefficient values. Very common for people to say, oh, don't mask out anything less than 0.3 so I can only see the strong correlations or the strong loadings if you like. In this case, I'm actually just going to ask it to sort it by size. I want to look at the output it creates. I just want to show you how you can graph some of this output manually. So if I click OK at this point and run that analysis, you can see it. We've got a communalities table here that tells me what percentage of the variation the resultant model explains in each of the variables. So you have like 91% effectively down to, let's see what's the smallest one, 57% of the variation for percent GNP for education. We can also see that it has by default extracted 6 components, and that those 6 components from 22 fields explain 84% of the data. So we've reduced the data down, the dimensionality of the data from 22 separate fields down to 6 components. And then we get our component matrix, which you could look at, but normally people look at the rotated component matrix, which makes it easier to explain. We can see that the loadings, the highest loadings for the first component here are related to life expectancy. So life expectancy in years and infant death mortality and life expectancy in years in 1960, they're all related. So that's kind of measuring that factor. And the next component here, we can see it's strongly related to things like energy consumption and radio. So that's kind of about the consumer societies and so on and so on. So each of these components measuring different things here. Education spending in component 3, loading high. If I wanted to graph any of these, if I wanted to create a chart, let's say, of component 1 here, I could just highlight that and say, okay, just right click and create a graph from that. And it creates a bar chart for me. So it's actually just charting it. And that's what we want to do here. We want it to chart it. In fact, it would probably make sense for us if I ran that again. If I highlighted that, I just sorted it in order, so descending order, and then did it again, it'd make a cleaner looking chart. So yeah, so we can see that what the biggest components are, what the weakest components are as they get close to zero, and what the strongest negative components are that are related to this component 1. Could we use the OMS system to basically take this table, turn it into data, and then graph each of these components just as we done there automatically using syntax? Let's have a look at how we do that. So to do that, what we want to do is go to the Utilities menu and call up the OMS control panel. And this is where we can tell the output management system to look for the table that we're going to turn into data. Now, as we know, it is a table, so the output type is not a chart, it's not a heading, it's actually a table. You can see you can search and have it look for other types of output, but it's a table here. And the procedure we're running, as we can see here, is factor analysis. So I'm going to look for that, factor analysis. Now, if I scroll down in the background here, you can see that the table we're looking for is actually called the rotated component matrix. That's because we're running a principal components analysis. We don't actually have a table subtype that is labeled rotated component matrix. What we have is one labeled rotated factor matrix. That's the actual name, the OMS name, if you like, for that table. You can find out what names are associated with different bits of output for the OMS system by going to Utilities and calling up OMS identifiers here. So you can look up, for example, factor analysis there, and you can see here's all the different items or the different elements within that, and you'll see that there is in fact a rotated factor matrix. So that's what that table refers to, the rotated factor matrix. So that's us identifying the object. Now we need to give this request an ID, and I'm going to call it comp ID, like that. I wouldn't give it a label. I think there may be a bug associated with that. At least in some occasions I find that it doesn't work. So I'm just going to leave it with comp ID. That's the request. And now I'm going to tell it where to put the data that's going to turn this output into. And I'm going to ask it, instead of punching it out into a file on a drive here, I'm going to actually ask it to open a data set. In the background, I'm going to call it PCA scores, PCA underscore scores. Okay. And that's me having defined the output management system control panel and telling it what to look for. Let's just recap on that using an annotated slide. So just to go through that again, there were a number of elements that we specified. First of all, we specified the output type. It was a table. Then we specified the procedure we were asking it to look for. And then we found the table type or the subtype within that procedure, which was the rotated factor matrix, which is actually labeled the rotated component matrix in the output. We give the request an ID, so the request itself is called comp ID for component ID, and we specified a name for the data set that we wanted to create, which it will create in the background. It's called PCA scores. And now, returning back to the output management system control panel, we're going to add this request to the live requests in the output management system by simply clicking add. And we're going to paste it as syntax too, because we're going to start to build up a syntax job now where we're going to ask it to look for this particular type of output so that we can turn it into data. So therefore we click paste. That gives us a little control panel summary dialog. Click OK at that point and it's pasted for us. Okay, now that it's pasted for us, we're actually going to paste in the syntax from the factor analysis procedure that we ran earlier. So I'm just going to use the recall dialog box button here to call that dialog back up again. There's the factor analysis pre-populated dialog. It's remembered all the settings from previous, and we can simply hit paste at this point. So now we're asking it to look for our key table, which is the rotated component matrix table. And we're going to finish up here by simply adding a command to tell it to stop looking, to stop monitoring, and that is simply a command called OMS end at that point. So if we run that procedure, what we should find is that we're asking it to look for this particular type of table, and we're going to ask it to once it found it, to turn it into a data set called PCA scores and open it in the background, and then having done that, to stop monitoring with the OMS end procedure. So we're just going to click run all here, we run all, we go to window, and we notice in the background here we got a little untitled data set labeled PCA scores open in the background. We click on that, we can see that it's populated with data and that the components themselves have been labeled A1, at 1, at 2, at 3, at 4, at 5. So now we're going to return to the syntax, and we're just going to rename these, give them more descriptive names, and create a chart and see how we get on with that. So returning to the syntax window, and bearing in mind now that I've got more than one data set open, I need to make sure that everything I do after this applies to the correct data set, and I want to work on the data set PCA scores. So I'm going to type in the dataset activate command just to make sure that SPSS understands that this is the dataset I want to apply my syntax to. So this is called dataset activate, and I just need to put in the label for that, which is called PCA scores. Done that. And I'm not terribly fond of the names that it's given the components. It has to do that because they started with a number, and SPSS won't allow variable names to begin with a number. So I'm going to use a rename variable command. I'm just actually going to paste that in. That's what that looks like. You can see I'm using rename variables. I'm saying just rename at 1, at 2, at 3, at 4, at 5, at 6 into component underscore 1, component underscore 2, and component underscore 3, and so forth. And I can run that. I can run that section. Just say okay. Just make sure I'm running that selection. If I come back to the data set, and I can see that the variables have indeed been renamed successfully here to component 1, 2, 3, 4, 5, 6. At this stage, I'm starting to think about, well, I want to create a chart of these scores. Bearing in mind, I've only got 22 cases here. Each case represents the scores for each of the variables that went into the principal component analysis and their respective loadings on each component. And there's a chart I can run here. If I go to graphs and go down to the legacy bar charts, go to the legacy bar chart here, I can say, actually, I just want values of individual cases. You can see you've got summaries, groups, cases. This option here, values of individual cases, that's what I want. And I simply say, well, look, I just want you to show me the values of component 1 here. Click OK. That produces a chart for me. And sure enough, it's graphing them just as it did at the start, where we manually created this chart. But it's not doing it in an order of magnitude. So I might want to sort that variable in order, in which case I want to do that in syntax as well. So I'm going to go to the syntax here, and I'm actually going to run a command to sort the first field in descending order by the values within that field, the value of loading. So I'm going to type in a command which is simply sort cases by, and of course it's called component 1, so you can see it's coming up here as component 1, and I really want it in descending order, so I'm going to put in descending order, full stop. Let's see if that works. Sort cases by component 1, run that. It does look like it's sorted in order. I can now rerun my chart that I did earlier, so I'm just going to call up the define simple bar chart. I'm actually going to ask it to label it by this field which shows, you know, the name of the variable. So I'm going to say by this this field here, which is simply called var1. If I click OK at that point, you can see it produces a much more pleasing chart. Now you notice that it's labeling every second field, every second row, if you like. I really don't want that, so I might want to edit this. And if I edit it, I could save that as a template, and then apply the template to the chart and to all subsequent charts. So let's have a look at doing that. And I'll begin simply by double clicking on the chart to open it up into an editor. And if I double click on the axis along the bottom here, I'll be able to edit that. And one of the first things I'm going to do here is just change the font size. If I make it a smaller font size, I can see the labels for all of the individual variables. I can also change things like the colors of the bars as they appear. Change them. I could change the background here as well and say, okay, I want to change this background to pale yellow and hit apply at that point. And if I get to a point where I'm happy with that, I can go to File and say I want to save this as a template. If I click all settings, it'll probably apply things like the titles as well. I don't really want that, so I don't want these axes titles or anything like that. So the text format, so I don't want that. But I can leave pretty much everything else, the text formatting, etc. And then hit continue and put it into a folder that I can work with on a regular basis. So I've got a little folder here for OMS work. I'll call it component template. And there we go. Hit close that down. And if I now return to syntax, I'll be able to add the syntax for this chart, as well as the syntax that requests that template is applied to it. And I can do that simply by calling up the dialog box again. This time checking the box marked use chart specifications from, looking for my template, which is called component template. Click open that point and then hit paste. Let's just check that and see if it works. There's the syntax for the graph, that we the chart we just created. Let's hit run, and as you can see, it's applying that correctly to the component bar chart. Now all we've got to do, of course, is just repeat this process by copying and pasting and changing the name of the field that we're analyzing from component 1 to component 2 to component 3, etc., etc., so we can build up our batch job. So let's just jump back to syntax and do that quickly. Finally, back in the syntax, all I need to do is copy the last piece of syntax for the sort cases and the chart syntax 5 more times. I'm just going to do that. And then I go back up and change the names of the variables that we're asking it to sort by and chart. And as you can see, I've just edited the pasted syntax so that it's now producing charts for component 2, 3, 4, 5, and 6. And finally, to test the entire syntax job, we can simply return back to the original data set and we can see if it works. So returning to the original world.sav dataset, we've only got that open and the syntax. So we're going to rerun all of the syntax again, just run all. You can see it creates the PCA scores dataset, and if we look at the output window now, the output viewer, we can see that the 6 charts that chart the scores in the rotated component matrix have been created. So we've effectively taken output, turned it into data, and created another form of analysis of that output in the form of these charts that show the loadings on each of the components.